Gaseous Mass Hypothesis by Immanuel Kant. Good morning, everyone. Today, I am going to explain the gaseous mass hypothesis, proposed by the German philosopher and scientist Immanuel Kant in 1755, along with its criticisms. Introduction. The gaseous mass hypothesis is one of the earliest scientific attempts to explain the origin of the solar system. Kant suggested that the sun, planets, and other celestial bodies originated from a vast cloud of hot gases and dust spread throughout space. His ideas were later developed independently by the French mathematician Pierre-Simon Laplace, and together they became known as the Kant-Laplace nebular hypothesis. Main idea of the hypothesis. According to Kant, in the beginning, there was a huge cloud of hot, diffuse gas and dust, known as a nebula. Due to the force of gravity, the particles in the nebula gradually attracted one another and began to collapse inward. As the cloud contracted, it started rotating faster because of the conservation of angular momentum. The rotating cloud flattened into a disc-like shape. Most of the material accumulated at the center, forming the sun. The remaining material in the rotating disk condensed into smaller masses, which eventually became the planets and their satellites. Over millions of years, these bodies cooled and developed into the solar system we observe today. Importance of the hypothesis. The gaseous mass hypothesis was significant because it provided one of the first natural explanations for the formation of the solar system. It explained why the planets revolve around the sun in nearly the same direction and in almost the same plane. It encouraged later scientific studies on planetary formation and laid the foundation for modern nebular theories. Criticisms of the gaseous mass hypothesis. Although the hypothesis was revolutionary, it has several limitations. It could not adequately explain how angular momentum is distributed. The sun contains almost all the mass of the solar system but only a small fraction of its angular momentum, while the planets possess most of it. The hypothesis did not clearly explain how the planets condensed from the gaseous disk without breaking apart or falling back into the sun. It assumed a uniformly rotating nebula, but modern observations show that the formation of planetary systems is more complex. It did not account for the differences between rocky inner planets and gaseous outer planets. Many details of the original hypothesis have been modified by modern astronomy, which includes processes such as accretion, collisions, magnetic fields, and interactions within protoplanetary disks. Conclusion. In conclusion, the gaseous mass hypothesis proposed by Immanuel Kant was a landmark idea in astronomy. Although some aspects of the original theory have been revised or replaced, its central concept, that the solar system formed from a rotating cloud of gas and dust, remains the basis of the modern solar nebular theory. Kant's work marked an important step toward understanding the origin and evolution of our solar system. Thank you.